Hello everyone, welcome to the session. Today we'll understand what DevOps is, why it exists, how modern software is delivered faster using automation, and we'll also discuss why this matters to our careers. So, have you ever used Instagram, WhatsApp, Zomato, or any social platform and noticed that new features keep showing up regularly and wondered how these apps keep updating so frequently without breaking everything? So, here where DevOps comes in. DevOps helps companies release software faster, safer, and more reliably. This is what this session is about. This session is not about memorizing tool names, but it is about understanding how companies like Amazon, Netflix, Swiggy, and Google release new features to millions of users every single day without causing chaos. To understand why DevOps exists, we need to go back to how software was built before it. Before DevOps, teams worked in silos. Developers wrote code, testers tested it, operations team deployed it. These were completely separate groups who barely talked to each other. So, what do you think had happened when something broke in production? Well, developers said it worked on my machine, and operations said the code is broken, while testers says that we tested the whole thing and everyone had someone else to point at. So, but the real issue was not people being lazy. The real issue was the process. Software was moving slowly from one team to the next team with hands off, delays, and miscommunication at every step. But by the time a bug was discovered, the code was already in the hands of a user. So the result of this way of working was four major problems, and here we can see the slow release where we take weeks or months between updates, and every time we needed to be tested or deployed, a human had to do it step by step, and eventually we'll be having more errors because bugs were found so late in the process, sometimes only after the software was already given to the users. And now nobody owned the end results because developers blame the testers blame the operations, and at the end operations blame the developers as well. And so the customers just experienced a broken product and didn't care whose fault it was. So DevOps was born directly from the pain of this model. It's the industry's answer to the question, what if we stopped working in silos and instead build a software as a continuous, collaborative, and automated process? There's a quote which says that traditional delivery is like submitting an assignment at the end of the semester and finding all the mistakes in. So DevOps is like checking and improving it continuously while you're writing it. So that's it. That's the whole difference in one sentence. Now, think about it from your own experience. While you're writing an assignment and you only check it once, like right before submission, what happens? You'll find a lot of typos, wrong facts, missing sections, and what? Panic sets in. You don't have time to fix everything properly, and then you submit something that's not your best work. But if you're checking as you go, like sentence by sentence or section by section, you catch mistakes early while they're still small, and the final result is dramatically better, and you weren't stressed at the end, right? So that's what the traditional model did to software teams. You only found out how broken things were at the very end when it was most expensive and painful time to fix them. The core difference isn't just a process change, it is a cultural shift, and that's important to understand because DevOps isn't a tool you install, it's a way of working. To make you understand in simple terms, let me put it like this, okay? DevOps makes the process continuous. Instead of passing work from one team to the next team like a slow relay race, it becomes one coordinated team moving together. So now students, let me give you a proper definition of what DevOps is. DevOps is a combination of development and operations. DevOps is not a programming language or not a single tool. It is like a culture and a process where it is a set of practices supported by tools. So the goal is to deliver better software faster with fewer failures. And now let me walk you through each pillar and give you a proper explanation. So the first thing is collaboration, where developers and operations are no longer work as strangers. They share responsibilities from day one, and then comes automation. So anything repetitive that a human has to manually do, like running tests or deploying code, or so they get it done by a machine. And machines do not get tired, as we all know. They do not get distracted or make any errors. Well, after automation, here comes the continuous testing. So instead of testing at the end, you test it every single time a developer pushes new code. So problems are caught immediately, not weeks later. Once continuous testing is done, we do continuous deployment, which is once the code passes all the checks, it can go to users automatically. They don't have to wait, or they don't have to they don't need any manual approvals. Once this is done, once the software is live, you can watch it in real time. If something breaks, you know it within seconds, but not days. So to emphasize it properly, DevOps is not something. DevOps is not about any one of these. It is all five working together. When you remove one, and the whole process gets slower and riskier. So students, let me bring this to life with an example that I think most of you can relate to. Imagine you are working at a food delivery company, let us say Swiggy or Zomato, okay? And the product team wants to add a new feature called, let us say, live order tracking, where you can see your delivery partner's exact location on map in a real time. Now, how does the feature go from an idea to being live in your hands? And now let me walk you through the DevOps cycle, where the product team decides what feature should do and how accurate the tracking be, and also how often should it refresh. So technically we have to make a plan, okay? And then once the plan is done, we developers write the code for the actual features. Once that is done, the code is converted and it is built into a runnable app. This is compiled and packaged into something that can actually run. Once this is done, the testers team automatically tests whether the tracking updates correctly, and whether the map loads, or whether it handles edge cases like GPS dropout. Once this is done, this is released. This is ready to go live, and then it is pushed to production servers where real users can now see it. Once this is done, the system keeps running, and if a server crashes, let us say if a server crashes, it restarts automatically. This is where how the operation looks like. But if an error rates up, for example, say that the map is loading slowly, or if a user is reporting an issue, the team sees these issues in real time and work on it. So notice that this is like a loop, but this is not like a straight line. So after monitoring, feedback goes to planning, and it's like a coming back to the first step. So every release makes the next one smarter. DevOps never really stops with that. So if DevOps lifecycle is the body, then students, what could be the heartbeat of DevOps? Let me walk you through this, okay? So the heart of DevOps is CI/CD, and you will hear these terms constantly in any DevOps context. So let's make sure you understand them clearly, all right? Okay. So every time a developer pushes code, which in a real team might get a dozen times a day, okay, so the system automatically run tests to verify that new changes works and doesn't break anything that already existed, okay? So here's why that matters. Imagine 5 developers are working on the same app. Let us say developer A changes the login system, and developer B adds the order tracking feature, which we just talked about. Okay, developer C is refactoring the database layer. Now, without CI, nobody finds out these changes where they're conflicting with each other, while someone manually runs the whole app maybe days later. So with CI, every push triggers an automatic check. Conflicts are caught in minutes but not days. And here CI stands for continuous integration. Now let's talk about CD. CD is either continuous delivery or continuous deployment. So once the code passes all the CI checks, it automatically moves towards production. In CD, it's tagged and ready a human presses the final button. Okay, in continuous deployment, even the button is automated. No human had to give any confirmation because the code passes tests and code goes live, so no manual handoffs. So CI/CD is like an automatic quality check system where every change gets checked before it can move forward. If it passes, it goes, but if it fails, it stops right there. So this is why teams can ship multiple days a day, not because they are rushing, but because every change is automatically verified before it goes anywhere near a user. So students, now if you have been reading about DevOps online, you have probably encountered a wall of tool names, and I know it kind of feels overwhelmed. So here's the reframe I want you to carry throughout this course. Do not panic when you see these tool names. You do not have to learn DevOps by memorizing a list of tools. You can learn DevOps by understanding what problem each tool solves. Now I'll walk you through the table, so it you'll get a better picture of what these tools are used for. First, GitHub. Every day a developer needs somewhere to store and track code changes, so GitHub does that. And GitHub Actions and Jenkins. So someone needs to automatically run the pipeline. So these tools do that. So when you push the code, they are the ones running your tests and builds. And Docker. Here is a classic problem. Code works perfectly on developers' laptops, okay, but fails on the servers. Here, developer solves this by packaging the application along with everything it needs to run. You ship the environment, not just the code, okay. And now Kubernetes. Once you have dozens of Docker containers running, someone needs to manage them. So here, what Kubernetes does that at scale. Now the cloud one. So AWS, Azure and GCP, these are the cloud platforms. Instead of buying and maintaining a physical servers, you rent computing powers from these providers. Later, Prometheus. So once your app is live, you need to see what is happening. So Prometheus collects data and Grafana makes it visual. So to reinforce the key point here is DevOps is not a tool, okay. DevOps is a culture and a process, and these tools are what helps you implement it. So students, let us put everything together with a real example, okay. So let us say Swiggy wants to ship a new feature, which is showing the delivery partner's exact location on the map in real time. Now what DevOps version, now let's look what DevOps version step by step. So the developers write the features and pushes the code to GitHub. Now the CI pipeline immediately picks this up and runs automated tests. So no one had to manually trigger anything. Once the tests pass, the CD pipeline takes over and deploys the feature, but not to every user at once. So it deploys to maybe 5% of the users first. So this is called a canary release, where monitoring tools are watching. So if error rate spikes or the app starts slowing down for the 5%, the team gets an alert immediately. So if something goes wrong, one command rolls the change back, because so no one had to stay up all night manually fixing the production. So the damage is contained to the 5% of the users only, and it is reversed in minutes. Then contrast with the old way. So without DevOps, this feature might have taken 2 weeks to test manually, then been deployed to everyone at once on some Friday evening. And what? When something broke at 11 p.m., someone would have had to manually SSH into servers to fix it. So the key message here is DevOps does not eliminate mistakes. It makes mistakes smaller, faster to catch and faster to fix. So this is how companies reduce a risk while still moving fast. So let me crystallize everything we have covered into 3 simple points. So first, DevOps connect teams. It bridges the gap between the people who build software and the people who run it. And the second one is DevOps automates everything from building to testing and deploying. happens everything automatically. So the human effort goes into building features and solving problems, not running scripts manually. Because automation isn't about replacing engineers, it is about freeing engineers to do work that actually requires human brain. The final step, DevOps delivers reliably, because these teams ship faster with fewer failures and recover faster when failure do happen. Users get a better product which is more frequently. And I'll leave you with this closing thought from my slide. If development is about building the product, DevOps is about making sure that the product reaches users quickly, safely, and reliably. Like, that's the mission, and that's what you're actually learning to do. I know that you all have this question, why DevOps, and why now only. So here's a number worth knowing. Amazon deploys software changes every few seconds, not once a day but every few seconds. So 10 years ago, companies deployed once a month. Today, the best engineering teams deploy hundreds of times a day. So the speed of software delivery has become a competitive advantage. This means every company that ships software, which is now basically every company, needs people to understand how to do this reliably. This is a structural shift. DevOps is not a niche skill, it is becoming a table stakes. So students, so far we have learned what DevOps is, their pipelines, their tools, how every tool is being used. And now let us walk through why DevOps skills matters and how do they matter in real world. Every company that builds software, and that is now in every company, like across every sector, needs people who understand how to ship their software reliably. The demand for DevOps engineers is not a trend, it is a structural shift in how the industry works. So DevOps is one of the most accessible, high-paying path in tech, as you can see here on this slide. So you do not need to invent a new algorithm. You do not need to have a decade of experience, or you only need a solid understanding of the concepts, hands-on experience with the tools, and the ability to demonstrate that you can build the kind of pipeline where we have discussed today. So the combination, which is exactly what this course is designed to give you, is what you get in your interviews. So now let's talk specifically about what you're going to walk away with this course. You'll be having conceptual clarity, because there's a lot of noise around DevOps and people throw around a lot of tool names, and it feels overwhelming. But by the end of this course, you must have had a clear mental model for what every piece of puzzle does and why it exists. So that's the foundation everything else builds on. And later you'll be having a hands-on tool experience where you won't just hear about Docker, but you'll work with it. You won't just hear about CI/CD pipelines, you will build one by your own. The concepts we have talked about today, you'll implement every one of them, and implementation is what stays with you. Now, industry relevant skills are like every tool, every concept, and every workflow in this course maps directly to what real engineering teams use right now. So this isn't completely theoretical. This is what exactly in job description is. Next, you will have a way of thinking where the most underrated thing this course will give you is a mindset. Because the DevOps mindset, it is automate what's repetitive, test early, monitor everything, fail fast, and recover fast. This is how a strong engineer should think, regardless of what specific role you end up in. This way of approaching problems will make you better at it. And now the curious question you would be having is, what kind of career opportunities I'll be having with these skills. So as you can see here, the first is DevOps engineer. It is the most direct path, and it is one of the highest paid roles in the industry. So these engineers own CI/CD pipelines, the container infrastructure, and the cloud environment. So everything we have covered today is their domain. And next is SRE, which is Site Reliability Engineer. It is a related role where pioneered by Google that focuses specifically on reliability and scalability of production systems. And later we have cloud engineer, where they focus on designing and managing cloud infrastructures, like we spoke about AWS, Azure, and GCP. As more companies move everything to the cloud, the demand here is enormous. So we do have a good scope in cloud engineering here. And next is platform engineer. So they build the internal tools and platforms that other developers use. The kind of CI/CD system we described today here, that is what platform engineers build actually. And here's something really important. Even if you go into software development as a backend or full stack engineer, understanding DevOps makes you significantly more valuable, because a developer who understands how their code gets deployed and how it is monitored and how it is built is so that developer is in a different tier entirely. So now, everyone, I want to leave you with this. You are at an interesting moment, because DevOps is mature enough that there are clear paths to learn clear tools that are industry standard, and massive demand for people who know it very well. But it's still very early though. That the bar to stand out isn't impossibly high, because a strong capstone project, solid fundamentals, and hands-on experience with code tools will genuinely set you apart. So everything we have covered today, from the life cycle, CI/CD pipeline, containers, monitoring, and the real-world example with order tracking, that's your whole map. So this course is going to take you from that map to actually building the territory. And I'm really excited to go through this with you. So let's get into it. Thank you.